Welcome to MechTech 40. Let's start with the trapezoidal rule today. So here, as per the formula, general formula, if we will, it's a integration method. So if we will take y dx from x0 to xn, then as per the trapezoidal rule, we can get the integrated value by the formula h by 2 whole into y0 plus yn plus 2 whole into y1 plus y2 plus y3 plus up to n minus 1 terms. Here y0 is what? Y0 is f of x0, y1 is f of x1, and similarly y2 and yn we will get by putting xn and x2 etc. in the function and the interval of width h, and it can be of even number of intervals or odd number of intervals. It can be of any value, but that has to be of width h, right guys? So let's come to the geometrical significance of trapezoidal rule. Here this is a curve, and we say this as y equal to f of x. So while drawing the graph or the curve y is equal to f of x, we are taking the interval from a to b and we are doing the integration from x0 equal to a to x3 equal to b. So as per the trapezoidal rule, the integration should be y dx. So it has to be the shaded area under the curve y equal to f of x. But in case of trapezoidal rule, we are joining the curve from x0 equal to a and y1. Similarly x1 and y1, sorry, x0 and y0 we are joining, x1 and y1 we are joining, similarly x2 and y2. So this value will be y0, this value will be y1, and similarly corresponding to x2 we will get y2. Okay guys, so this will be y2. So we are joining y0 with x1, similarly y0 with x0, y1 with x1, and y2 with x2. So now we'll integrate. So the as per trapezoidal rule, the integration will be the shaded area, and that will be sum of area of three trapeziums. Similarly, in case of general formula, it is the sum of areas of the n trapeziums. As as the graph shows it here, these are trapeziums, right guys? We are taking small intervals and it is assumed as trapeziums. So as per the formula, we are taking the areas of all the trapeziums, that is n trapezium, and we will get h by 2 whole into first term into last term plus 2 whole into rest of the terms, that is rest of the functional values corresponding to the x. Right guys, then next come to Simpson's one-third rule. And Simpson's one-third rule, or simply Simpson's rule, it should be noted that this rule requires the division of the whole range into an even number of subintervals of width h. Okay, means here last term yn has to be a even term. Okay, that is multiple of 2. Okay, 2 into x. So number of interval has to be a multiple of 2. That is even number interval has to be there. Okay guys. Like you can say it can be of 7 points, but 6 intervals. That is your what? That means even number of intervals. So you can apply Simpson's one-third rule. Always mark while applying this that you should be dividing the whole range of A to B in equal number of even intervals. Okay, so this is the point which has to be a note. Okay, so this is our note that Simpson's one-third rule is applicable when there are equal width of even number of subintervals. So as per the formula, x0 xn ydx equal to h by 3, that is the width of the interval, whole into y0 plus yn, that is first term and last term, plus 4 whole into y1 plus y3 plus etc., plus 2 whole into y2 plus y4 and rest of the terms. So 4 into y2n minus 1, generally we can say this, and plus 2 whole into y of 2n. Okay guys, so these are the general formula. Then come to Simpson's 3 by 8 rule. Here Simpson's one third rule, that has to be, there has to be even number of intervals, even number of sub intervals. Okay, in case of Simpson's 3 by 8 rule, it has to be a multiple of 3. Okay, it has to be a multiple of 3, the number of intervals of equal width, that is h. So as per the formula, x0 whole into xn y dx equal to 3h by 8 whole into y0 plus yn plus 3 whole into y1 plus y2 plus all the rest of the term plus 2 whole into y3 plus yx plus etc. So it can be a trick guys. I would say it will be easy for you to remember if you do like this. In case of Simpson's one third rule, h by 3, and in case of Simpson's 3 by 8 rule, it is 3 by 3h by 8. Then first term and last term, in both the cases that is common. Here in case of Simpson's one third rule, we are using what, 1, here it is 1, it is 4, and it is 2, and it is 1, 3 and 2. So here it is 142 and it is 132. In case of 2, we are using y3 plus y6 etc. in 3 by 8 rule, and here in case of Simpson's one third rule, we are using y2 plus y4 etc. and for rest terms we are using 4, and here for rest term we are using 3. Okay, so it is a even interval. So with 2 we are multiplying y2 plus y4. Here the sub interval has to be multiple of 3. So we are multiplying with 2 y3 plus y6 etc. So this can be a short trick for you guys for remembering the formula. If possible, I would say it again. In case of Simpson's one third rule, remember it as 1, 4, 2. In case of Simpson's 3 by 8 rule, it can be 1, 3 and 2. And Simpson's one third rule, we need even subintervals. So with 2 we are multiplying 2, 4, 6 etc. In case of Simpson's 3 by 8 rule, for multiple of 3 interval subintervals, we are multiplying with 2 y3 plus y6 etc., and rest of the terms we are multiplying with 3, and here we are rest of the terms we are multiplying with 4. Okay guys, so this is for today. Thank you.